Today we're going to be talking about how to multiply polynomials. We're going to basically go through four types. The first one is multiplying monomials times monomials, which actually we've already done. The second one is a monomial times a polynomial, then a binomial times a binomial, and then any polynomial times any polynomial. So to multiply monomials and polynomials, you're going to use some of the properties of exponents that you learned early in this chapter. So remember, when you're multiplying powers that have the same base, you keep the base and you add the exponents. So when you're adding or subtracting polynomials, you do not change the exponents, but when you're multiplying, you do change the exponents. So let's start off with multiplying monomials. When you're multiplying monomials, all you do is you multiply the numbers times the numbers, and then you multiply the letters times the letters by adding their exponents. So in example A here, you have 6 times 3, which is 18, and then y to the third times y to the fifth is y to the eighth. So we have 18y to the eighth. In example B, 3 times 9 is 27. The exponent of m, there's an understood 1, so m to the first times n to the second is m to the third, and n to the second times n to the first is n to the third. So this is multiplying monomials. Multiply the numbers and multiply the common letters by adding their exponents. Next, we're going to talk about multiplying a polynomial by a monomial. When you have this, you just multiply by using the distributive property. So 4 times the polynomial 3x squared plus 4x minus 8, you distribute the 4 to everything in parentheses. 4 times 3 is 12, and then it's x squared. 4 times 4x is 16x, and 4 times negative 8 is negative 32. Make sure none of these are like terms, can't combine them, so that's our final answer. When you multiply 6pq times the quantity 2p minus q, you distribute the 6pq. 6 times 2 is 12, p times p is p squared, and then you still have the q. And 6pq times negative q, that's negative 6pq squared. A monomial times a polynomial, you distribute. When you have a binomial times a binomial, you can also use the distributive property. Essentially, you have to multiply every term in the first binomial times each term in the second binomial. So you multiply the x times the x and multiply the x times the 2. And then you also multiply the 3 times the 2 and the 3 times the x. So you multiply x times x plus 2 and the 3 times x plus 2. I kind of feel like this method may be a little bit confusing, but maybe not. Maybe you understand it. If you remember last week, I was wearing my foil t-shirt, and the reason I was wearing my foil t-shirt is because foil is one method you can use to multiply binomials. And the foil method, it's called that because of the way that you multiply binomials. The F stands for multiplying the first terms in each binomial. X times x, those are the first terms, and that's x squared. The O is for you multiply the outside terms. The x times the 2 is 2x. The I is for the inner terms. You multiply the inner terms, the terms on the inside. And then the L is for the last terms in each binomial, 3 times 2. Once you get all those products, you combine them by their symbols. These are all positive, so it's going to be all addition. X squared plus 2x plus 3x plus 6. And the 2x and 3x are like terms, so that gives you 5x. Let's do a quick example. If you have the binomial x plus 5 times the quantity x plus 7, it's a binomial times a binomial. So basically I'm going to multiply the x times each of the terms, and I'm going to multiply 5 times each of the terms. First times first. X times x is x squared. Outside times outside, x times 7 is positive 7x. The inside terms, 5 times x is positive 5x. And the last terms, 5 times 7 is 35. make sure we cannot combine like terms, but we can. 7x and 5x are like terms, so the final answer would be x squared plus 12x plus 35. That is the product of the quantity x plus 5 times x plus 7. This is a really important hint. When you have a binomial squared, a lot of times people want to say that that is x squared plus 25. You square each of the terms, but that is not correct, because that exponent 2 means you multiply the base times itself 2 times. So x plus 5 squared really means x plus 5 times x plus 5, which is something very different than x squared plus 25. Let's look at an example. If you have the quantity x minus 4 squared, that means x minus 4 times x minus 4. So we're going to FOIL this. First times first, outside times outside, inside times inside, last times last. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16. When you combine the like terms, negative 4x and negative 4x, you get negative 8x. So the final answer is x squared minus 8x plus 16. And then here we have another example. First times first, 8m squared times m squared is 8m to the 4. Negative 3n is negative 24. M squared n. When you have more than one variable in one term, usually it's written in alphabetical order. So m comes before n, so I put that there. Inside times inside, negative n times m squared would be a negative nm squared, or put it in alphabetical order, m squared n. And then last times last, negative n times negative 3n is positive 3n squared. Combine the like terms, you have 8m to the 4th, negative 24m squared m minus m squared n is negative 25m squared n. And then you still have the plus 3n squared. So that is the FOIL method, when you multiply binomials times binomials. If you want to try this one on your own, you can try this. First times first, a times a is a squared. Outside times outside, negative 4a. Inside times inside, plus 3a. And last times last is negative 12. So that's a squared minus a minus 12. After you combine the like terms, that's how you get the minus a. When you multiply polynomials that have more than 2 terms, you can also use the distributive property, and essentially, you just have an extended version of the FOIL method. 5x plus 3 times 2x squared plus 10x minus 6. When you have a problem like this, you want to multiply each of the terms in the first polynomial times each of the terms in the last one. So you're going to multiply the 5x times the 2x, and the 5x times the 10x, and the 5x times the negative 6. And then you're also going to multiply the 3 times the 2x squared, and times the 10x, and times the negative 6. So 5x times 2x is 10x cubed. 5x times 10x is positive 50x squared. 5x times negative 6 is negative 30x. Now to multiply everything times 3. 3 times 2x squared is 6x squared. 3 times 10x is 30x. And 3 times negative 6 is negative 18. The last thing you're going to do is combine like terms. There's only one cubic term. There's 2 quadratic terms, 50x squared and 6x squared, so combined together that makes 56x squared. The linear terms, negative 30x and positive 30x, cancel each other out, and then negative 18. That's the method that I use to solve polynomials times polynomials, but there are 2 other methods that you could use. There's the rectangle method, which I'm going to show you here. In the rectangle method, you put one polynomial along the top of the box, and the other polynomial, essentially it's like finding the area of each little squared, etc. And then all of the things inside are the terms that you add together and you simplify. And then the vertical method, it's basically just like you do when you multiply long numbers that you learned in, I don't know, 3rd grade. About to the terms, then you shift over one space and multiply the other term by all of the other terms and together. So we're going to do an example with both of these, rectangle and vertical method, and then there's the horizontal method, and you can choose which one you like best. Let's start with the rectangle method. If I want to use the rectangle method for this, I have x squared plus 4x minus 6. I'm going to write that along the top of a box. I'm multiplying it by x minus 5. So now, what's the product of x squared and x? That's x cubed. The product of x squared and negative 5 is negative 5x squared. The product of 4x and x is 4x squared. The product of 4x and negative 5 is negative 20x. The product of negative 6 and x is negative 6x. And the product of negative 6 and negative 5 is positive 30. Now you still have to simplify. And you know, this is kind of like that lattice method of multiplication that some of you may have learned. There is not another cubic term, so you have x cubed. I've used that. Now, negative 5x squared and 4x squared, those are like terms. If you combine negative 5x squared plus 4x squared, you get negative 1x squared. Negative 20x combined with negative 6x is negative 26x. And then you have positive 30. And that's the final answer. Using the rectangle method. We could also use the vertical method. So I'm going to write the polynomial with the most terms on the top, and then the other polynomial below it. And just like I was multiplying large numbers, I'm going to multiply negative 5 times all of these things. Negative 5 times negative 6 is positive 30. Negative 5 times 4x is negative 20x. And negative 5 times x squared is negative 5x squared. And then you shift over one spot, and x times negative 6 is negative 6x. X times 4x is positive 4x squared. And x times x squared is x cubed. And then you add these up. So you have positive 30, negative 26x, negative x squared, and x cubed. And both ways we got the same answer. So you can choose which method you like the best, the horizontal method, the rectangle method, or the vertical method. I'm not going to work out this example. This is just another example that we could try. And then here's an application. You have a rectangular prism that's 3 feet less, the width is 3 feet less than the height, and the length of the prism is 4 feet more than the height. I didn't have an actual problem. Perhaps we want to find, we have length and the width and the length. Never mind. There's not an actual question. All right. Why don't you try these 6 questions, answer them, and when you're finished, you can put this away, bring them to class with you tomorrow, and we'll check them in class.